Hola, and thank you for the invite to speak at the conference. I'm very happy to share our experience of designing and building Old Holloway, which is our own passive house in Herefordshire in UK. It's a project that was completed about 4 years ago. We have lived in it since then. Here are some basic statistics. I'm not going to go through all of them in detail, but it's a relatively small house, just under 100 square meters. Unfortunately, form factor is not very favorable. It's about 4.6, but it's due to certain site constraints. I work as an architect, as a passive house designer as well. I was kind of responsible for design and then for the passive house side of things. The main builder was Mike Whitfield, and also had some help from Alan Clark, Nick Grant, and many other specialists. Here are the passive house certificates, and the project also won UK Passive House Trust Award in 2018 for small projects. So very briefly, it's a south-facing site. It's on top of a hill. If you imagine rolling hills in Herefordshire, we are overlooking the south side of Herefordshire with far-reaching views. We are kind of surrounded by a cluster of existing houses, but there's very little shading coming from either east or south. There's a little bit of shading on the west with some high hedging, but generally speaking, it's a very sort of open site. So there were some existing small buildings on the site before we built the house. There was sort of agricultural sort of nature, small huts, and we decided to locate the new house at the northern part of the site, really to sort of maximize the potential of the site and maximize the views. The site we also sort of cut into the ground to lower its impact to neighbors and just kind of sit within the landscape really discreetly. Here you can see on the left the original site, so the two small huts at the bottom left, and on the right hand side the kind of proposed design with the house added to the northern part of the site. It's kind of not far off how it actually ended up. So just a little bit about the design process, the massing study. So we sort of started off from a conventional 2-story high house-like building with a fairly conventional pitched roof. And then in order to kind of minimize the visual impact on neighbors, we dropped the massing to a single-story, which meant that we had to increase the footprint of the house. We then also lowered the roof pitch further to about 30 degrees. That sort of ties in with roof pitches of the kind of neighboring properties and minimizes the impact further. And then lastly, we created this veranda to the south elevation, which provides a good shading and just provides this kind of added living space, which is external. And on the right hand side, there's a very sort of basic schematic of how the house is designed or laid out. So in the central part is very sort of open plan accommodation. So that is your kitchen, living room, and dining. At the top is actually the kind of western wing with 2 bedrooms and the main bathroom. And at the opposite end, behind the living room, there's an office or something that can double up as a spare bedroom with its own ensuite shower room. Here is a sort of larger version of the floor plan. It just kind of shows the flexibility of the layout. The house can function as a 2-bedroom or a 3-bedroom house, kind of depending on the needs of the occupants. I mean, I was very happy to spend the previous 18 months during lockdown in the office and kind of worked from home. That worked really well. I'm now sort of back in the main archetype office, which is quite nice. But yeah, it just worked really well during that pandemic. The section of the house is very simple, and we kind of used a little trick to increase the sense of spaciousness, and we sort of opened the ceilings up. So the internal space basically follows the pitch of the roof, giving it sort of bigger volume. And yeah, from outside the house seems relatively small, but internally it really sort of feels generous and spacious. On the section on the right, you can also see the kind of covered space outside of the south elevation, that kind of veranda, which is fully shaded in summer. In terms of elevations, we kept them deliberately very simple and kind of use references to local vernacular, simple agricultural sheds. So the window design is also very simple. The windows are designed to optimize views and daylighting, yeah, they sort of resemble simple agricultural buildings in the area. In terms of sort of materials, building materials and finishes, we kept them again very simple. So we used charred timber cladding, which is locally sourced, and corrugated roof, metal roof. Now, in terms of sort of summer comfort, again, the design was relatively simple. We sort of tried to design out overheating by this kind of south veranda that mainly provides the shading for the glazing facing south, but that was also complemented by some external blinds, roller blinds, which we have on, I think, 3 or 4 windows. And again, they provide good shading against the summer sun. MVHR unit also has an automatic summer bypass, so that helps us to keep the overheating to the minimum. And also the exposed concrete slab sort of acts as a bit of a sort of heat battery. So it helps to kind of smooth out the temperature peaks and troughs during the kind of heat waves. In terms of ventilation, we have a very simple ventilation system based on Zehnder ComfoAir MVHR unit. The medium rate is about 100 cubic meters per hour, and that's worked really well. Yeah, glazing is the usual kind of triple glazed system. And in terms of services design, the main space heating strategy is a wood burner. So we have a 4 kilowatt wood stove supplemented by 2 bathroom tower rails. So 1 in each bathroom, which is kind of running off the hot water cylinder. The hot water cylinder has a sort of integral air source heat pump. So that's a unit that is sitting inside a small plant room. Next slide is a very simple schematic of the ventilation system. So we kept it really really sort of optimized and simple. So we are supplying into bedrooms and into the main living space, and then extracting through bathrooms and the store. But yeah, kept it as a very kind of compact system. Now we'll get into construction. So what we try to do with the construction is to kind of use materials that have low embodied carbon and footprint. So this was the first example of using prefabricated straw panels by EcoCocon in UK. It's a high performance kind of panelized system that uses timber and straw, and it's also a certified passive house component. So we were really excited to use this as the kind of first customers in UK. And yeah, the process worked really well. All the panels are really sort of accurate. They're sort of made to measure, and they kind of work to millimeters. So the panels come together really easily, like a giant kind of Lego blocks. We had sort of really simple strategy for air tightness. Basically, the walls are wrapped in air tightness membrane from the outside, and then additional wood fiber insulation is installed before the final facade is installed as well. But we'll get on to details in a little while. So this image is an example of the panel project. So basically, once the architectural design was done, the drawings were modeled and panelized by EcoCocon, and yeah, this kind of just showed all the different panels that went together. And it's a very simple and intuitive way of visualizing how the construction comes together. Here we have a couple of examples of typical details. So on the left-hand side, we have a junction of external wall and a roof at the verge. So it's quite interesting to see on the external wall, obviously the air tightness membrane was running on the outside, but then for the roof, it switched to the underside of the roof. So it was important to maintain that continuity of air tightness layer. For the actual roof, we used timber I-beams, and for insulation, we insulated the roofs with recycled cellulose called warm cell. So all the gaps in the roof were fully filled. Now it's probably important to mention the air tightness membrane for the walls is actually very vapor open with a really low SD value. So there's minimal kind of risk of condensation in those walls. Now the detail at the right-hand side just shows the foundation detail. So the straw panels are sitting on the edge of insulated concrete foundation. Again, kind of showing no significant thermal bridging there. And here we have a typical sort of window installation detail. Again, sort of showing how we have sort of minimized the thermal bridging in that installation. We sort of positioned the windows approximately in the middle of the wall assembly, that is the optimal location for a window in terms of heat loss point of view. At the head and the window jambs, we have sort of wrapped the window frames with the wood fiber insulation, so that sort of minimized the heat loss even further. Okay, now we're getting on to some site photographs. So starting with the insulation under the foundations. So we had 250 millimeters of EPS insulation. And this system was ISOQUIC. It included integral upstands at the edges. So that provided its own kind of insulated shuttering before the concrete was poured. Here we see the concrete pour with some reinforcement in the slab. This was a very hot day, so we was, guys were really working hard to make the concrete sort of nice and smooth. Then the concrete slab provided us with a good base for building the straw panels, and the external walls went up really quickly. I think all the walls went up in 3 days, and the roof took another sort of week or so. So it was, for us, it was really really great to have the building sort of weather tight within a short period of time. Here we see the roof members. So it was a combination of 400 millimeter I-beams generally and 200 millimeter I-beams with 200 mil of solid timber beams that were sort of cantilevered out to form the veranda. And again, that detail was achieved, the kind of almost zero thermal bridging, but it was all part of the kind of really detailed planning during the design stage. Here we see how the panels looked from inside during the build. So it's actually one of the great advantages of this system was that it's a very dry system. There were at that point very few kind of wet trades, so it was really nice to kind of work in that environment during the construction. On this photo, you see the plywood boards around the window openings, and those were also part of the air tightness strategy. So all the corners in the plywood were taped before the windows were installed. And this shows a junction between walls and the roof, where the membrane from outside is switched to the inside, and then is taped onto a glulam wall plate, and then later on there was a membrane applied to the underside of the I-beams. Excuse me. And yeah, so we made sure that the air tightness layer is continuous. This is just some pre-taping of windows before the installation, and insulating the roofs with recycled paper. That was quite fun. I think we had many tons of shredded newspaper in the roof, which is keeping us nice and cozy. Obviously, as on every passive house project, we had to do a couple of air tightness tests, and we passed quite comfortably. This is the first air test that we've done once we had all the windows in, and all the air tightness was kind of taped up and achieved. So the first test achieved about 0.4 air changes per hour. And you can see in the picture a very small fan that was installed within the window rather than usually a larger fan is used in the door. You'll also notice a small wood stove here in the corner. That was one of the kind of weak points in terms of air tightness because, inherently it is a penetration through the air tightness envelope. But even the large sort of sliding door was relatively airtight, so there were no major sort of air leaks through that, as you know we have shown here with a smoke test. Then we sort of carried on with installation of internal sort of partitions. We added really dense plasterboards called Thermocell. So this also kind of helped us achieve more thermal mass in the house. Obviously, straw being quite lightweight, we tried to put a bit more density in the construction. And this is installation of acoustic timber ceiling with my dad. That was really fun. And then we embarked upon a long process of clay plastering of all the kind of straw panels. So Roman from Slovakia, he was an excellent plasterer. So we spent about 7 weeks applying several layers of clay plaster onto the straw walls, and this really provided a great finish that sort of is low toxicity, very natural, and it doesn't need kind of painting, and it's a great combination with straw in terms of kind of achieving good air quality inside and this kind of feeling of solidity as well. Just some details of preparation before the clay plastering around windows. So we applied some reed mats onto the plywood panels to improve the kind of key for the clay plaster. And this is a kind of finished corner. So Roman came up with this kind of idea of a curved reveal, which is really kind of gives it a nice sculptural kind of form, and the finished product there. Then we obviously had to commission the ventilation. So Nick Grant and Alan Clark came around to commission the ventilation system, which was great. And yeah, it's been running really well since then. We also had fun charring the cedar cladding on site, although it took quite a long time to do. I think the final sort of effect was worth it. Here we see a large scale detail of a typical window installation from the outside, and this includes an external blind, roller blind, so that we use that during the summer months, or even sort of spring and autumn when it's really sunny. And the great advantage is that it also acts as a bit of an insect screen. So we can leave the window open behind it, and yeah, it's just a really good product and good concept. And a few photos from inside. So yeah, the kind of open ceiling of the main living space with clay walls. So this is showing the kitchen, dining, and living room. This is a shot from the other side. Midge, our spaniel, is enjoying the comfort of this house as well as we do. and just a photo of the exterior of the veranda. So sometimes in summer we sort of extend the covered space by this kind of sail, external sail, and that just provides extra bit of shading for that timber decking. It doesn't provide any more shading to the interior, but it's just nice to be kind of sitting outside with friends. Now this is a shot of the winter. The first winter after we moved in, we had this spell of really cold weather called Beast from the East in 2018, and it was a first huge test of how the house is going to perform, and it was absolutely fine. Just a few more interior shots. Now, I'd just like to cover a few things on the performance. So since the completion, we have been monitoring the temperature, CO2, and acoustic levels inside, and humidity. So the graphs on the one on the left shows the kind of summertime. The graph at the bottom is the interior temperatures. So it's kind of hovering around 20 degrees C, even during the kind of heat waves. So the blue line is the inside temperature. The red line is the external temperature. So even with temperatures sort of nearing 30 degrees, the inside kind of stayed well below 25 degrees C. And then the graphs on the right-hand side is the kind of winter time during the Beast from the East. So again, the red line is the external temperatures. So for a period of about a week or 10 days, it went sort of well below zero, which is quite unusual for UK. But again, the inside temperatures barely touched or changed during that period. So they were, fluctuating just above 20. Now, in terms of the heating demand, the PHPP predicted just under 15, but the actual heating demand, kind of based on the wood that we burned over that sort of really cold winter, came to about 9.5 or around about 10 kilowatt hours per square meter. Just for comparison, last winter we burned 1/3 of a cubic meter of wood, so it would be even lower than that. And I'll come on to the question of wood burner in a short while. And again, yeah, this kind of shows a larger version of that summer heat wave. Again, showing the external temperature in red and internal temperature in blue. So yeah, kind of very stable conditions. Now, it was also very fun to join the Passive House Challenge earlier this year. Mark Siddle from UK on Twitter started this kind of fun little activity, asking residents of passive houses to basically stop the heating for a week and see what happens. So a few people on Twitter kind of joined this campaign, and it was just quite fun to see how the house would actually perform over that time. And in the end, it was really easy to kind of stay there without heating for a week. So it started on 19th of February. we turned the heating off. Outdoor temperature was it was relatively mild, sort of anywhere between sort of 4 and 10 degrees outside, but yeah, inside temperature sort of hovered between sort of 19 and 21. So again, yeah, it just showed that Passive House is very kind of resilient in terms of how it behaves in terms of power cuts, or if there, suddenly there was no power available, we'd probably be still okay for a while. And the next one is just to show our consumption of air source heat pump. So these are kind of weekly readings, and they sort of fluctuate during seasons. So the kind of summer performance is a lot better. Kind of weekly consumption is about 10 kilowatt hours per week, whereas in winter time it does go up to about sort of 70 kilowatt hours. Now, our original air source heat pump did malfunction last winter, so it had to be replaced. As you can see, for a short while we just used immersion heater, and the consumption went really high. But now the consumption is back to sort of where it should be. So at the moment, yeah, it's around about sort of 10 or 12 kilowatt hours a week, which is really good. And here are just a few thermal images, just kind of trying to find any cold spots. But as you can see, the hottest and coldest things are things like the television and a cold bottle of beer in the house. So yeah, very happy with how the system and the building has been sort of constructed with almost no kind of significant thermal bridges. Now, João, you asked me to include things that we would probably do differently. So now we've lived in the house for 4 years. I think it's become clear that the wood burner is probably not ideal for us. I mean, one thing, it's quite expensive. It was quite expensive to put in. We don't actually use it all that much. So if we did it again, we probably wouldn't install it, and instead we would put a mini split that would kind of supply the small bit of heating that we need, but also could supply a little bit of cooling in summer, just to kind of improve the comfort. We could also use the space better that's currently occupied by the wood burner. So yeah, I think the wood burners are really a thing of the past that we should just kind of forget about in passive houses and any other houses, to be honest. And the other thing we would probably look at is the foundations, because we are conscious that materials have a carbon footprint. So with the straw panels and timber roof, etc., we're sort of had sort of quite good credentials, whereas the foundation was still quite high in carbon. So we would probably be exploring alternatives for foundations that could include either suspended timber flooring or something like foam glass and limecrete or clay floors. So yeah, that would be definitely something we'd look at if we were building the house again. And obrigada. I think that's me done. Thank you very much.